my name is Katie, and today we are covering tutorial 3, and I'm here with my navigator. Hi, Linda.
Hey, this is Lindo. I'll be the navigator for this session.
So, I'm going to explain the code, and then I'll come back to the database. Okay, so I'm going to start with the config file. So here we have the runner config. Okay, so the configuration class, it defines the startup behavior for the application. Specifically, it wires a command line runner to fetch and print user data from an external API using the user REST client. Okay, so here we have a bean that's going to run once after the application context is loaded, and then it's going to use the user REST client to fetch all the users from the external API, and then it will print the results to the console for verification or debugging. We also have the client injected user control bean, and then it will also return the command line runner that executes the startup. So that's will fetch all the users from the API basically, and then this will just print the list of users in the console. And this is just for logging the result for the structured output. So now we have our in-memory run repository. So the in-memory implementation of a run repository stores run objects in a hash map for quick access. And then over here, we're going to return all the runs in the repository and list the list of run objects. Next, here we're going to find a run by its ID, and then the ID over here is just going to run the ID, and it will return an optional containing the run if found, and it will be empty otherwise. Here we create a new run, so the run param over here is just a run object to add, and then here we update the existing ID, the existing run by the ID, and then the run is the run object with the updated data, and the ID is the run to update. Next, here we're going to delete the run by its ID, and the ID is the run to delete. Then lastly, for this file, here we're going to find all the runs by location. So the location is to filter by, and the return is the list of run objects that are given that the list of run objects at the given location. So now we have the JDBC run repository. So it is the back implementation of the run repository. It uses the JDBC client to interact with the run table in the database. Next, we have a constructor. This is just the injection of the JDBC. Here we're going to retrieve all the runs from the database. And then over here, it's going to find the run by its ID, and then it will return an optional containing the run if it is found. Next, we are going to retrieve all the runs that match the given location. Here we're going to insert a new run into the database, and it's going to assert that exactly one row was affected. Next, we're going to update an existing run by the ID, and then we're also going to insert that exactly one row after the effect. Next, we are going to delete a run by its ID, and then it's also going to assert that exactly one row that was affected. Next, we do return the total of number of runs in the database, and then lastly, we do save all the runs by calling the create on each. Next, we have the enum location. So this enum is just the representation of all the locations for a run. So it's used to categorize runs as either indoor or outdoor. Here we have our run class. So this is the immutable data model representing a single running session. It includes the validations, uh, annotations, and derived metrics like duration and average pace. Here we have the integer ID, on line 14. So this is just a unique identifier for the run. On line 16 and 17, not empty string title. This is just a descriptive title of the run, and it should not be empty. The local date started on. This is just the timestamp when the run started. Here we have the local date time completed on. So this is just a timestamp when the run ended. Next, we have the annotation positive, so integer miles. So this is just the distance covered in miles, which must be greater than 0. And then we just have the location. This is just the enum indicating whether the run was indoor or outdoor. Next, this is where we compare the constructor with the validation logic. It also ensures completed on and chronologically after started on. Here we calculate the total of duration of the run, and then also we return the duration between the start and the completion. Lastly, we calculate the average pace in minute per mile, and then we also return the integer value of duration divided by miles. Now we have the run controller. So let me just do this. So the REST controller for managing run resources. It maps the HTTP request to the cloud operations via the JDBC run repository. Um, okay, so here we have a constructor injection of the repository. Next, we have a API. So here we are just going to return a list of all the runs, and then here we have another API, which is the get method as well. So it's going to return a single run by the ID, and if it does kick in an exception, it will throw a 4 if it's not found. Next, we have our post mapping. So this is a post request for the API. It's going to create a new run, validates the input, and it will return a 201 set is created. Next, we do have another put request API. So it's going to update an existing run by its ID, and then it also validates the input, and it will return a 204 with no content. We do have a delete API, so it's going to delete the run by its ID, and it will return a 204 no content. Lastly, we have a get API, so it's going to search for the location, and it will return all the runs followed by the location it was selected. Okay, so here we have the run JSON data loader. So this is just going to load the initial data from the JSON file and application starter, and it only triggers if the repository is empty. So here we also have a constructor injection of the object mapper and the target run repository. It does use the qualifier to ensure the JDBC run repository is selected. Lastly, for this file here, we're just going to execute it after the Spring Boot application startup, and then it's going to load JSON data only if the repository is empty. Um, oh no, okay. Next, we have the run found exception. So, okay. So this is just a custom exception thrown when a request run is not found in the repository, annotated with the annotation response status to automatically return a 44 if it is not found. So when this exception is thrown from a controller method, and then Lastly, we have a construct. This is a new run not found exception with a default message, so the message will include an HTTP response body if it's not overridden. So like it will say it run not found. So here we have the run repository. So this is just an exception for data access operations related to the run entities. And it also allows flexible switching between JDBC in-memory or mock implementations. And then over here, we retrieve all the runs from the data source, and then the return will just list all the run records. Here we find a run by its unique ID, and the ID is the run's identifier, and the return is the optional containing the run if found, or empty if it's not. Here we have void create run, so this is just a persist for a new run in the data source, and the run is to create a run. And then also here we have the update, so it's going to update an existing run by its ID, and then the run, which will be the updated run data, and the ID is the ID of the run to update. Here we're going to delete via ID, and the ID is the run to delete. Here we have the integer count, so this is just going to return the total number of runs in the data source, and then it will also return the integer of the count of the runs. So yeah, it's going to save a batch of runs in the data source, typically used for bulk inserts or initial seeding, and then the params run is just a list of runs to save. Lastly, yeah, we're going to find all the runs that match a given location. The location is a location filter, whether it's indoor or outdoor that we saw in the inner, and then it will return a list of runs matching the location. And then lastly, we do have the runs. So our runs class. So this is just a record for the list of run objects. It is for bulk operations like JSON, deserialization, or batch inserts. The structure allows Jackson to map the JSON object like runs and directly into the run instance. So here we have users. So when you create a user, you must have an address, a street, a suite, a city, or a zip code. A company, you create a company, so it must have a name, a catchphrase, and yes. And then the geo is just the latitude and longitude of the user. And then the user must just have an ID, a name, a username, an email address, a phone, a website, and a company. And then the user as client is for accessing the user data from the external API. It uses Spring's REST client to interact with an API with the JSON placeholder. So this component is useful for mocking external user data in development or testing scenarios. So you will have a constructor that builds a REST client with a predefined base URL. It uses REST client as a builder for flexible configuration. Next, yeah, we're going to fetch all the users from the external API, and it will return a list of user objects. Lastly, we're going to fetch a single user by ID of the external API. The ID is the user's ID, and the return will just be a user's object. I think I've covered everything here. So now I will be testing out the the database and as well as Insomnia. So okay, so I'm first gonna go over what my statements are, and then I'm going to run it. So here we're going to create a user table. Like I showed you in the code, the user table must have an ID, which is the primary key, a name, a username, an email, a phone, and a website. This is the data that we're going to insert for a user. So here we have ID1, a name, a username, a email, a number, and a website, I believe, a phone and a website. So this is going for every single person under ID number 10. Next, we're going to insert a new user. So here we have the ID, here we have the name, the nickname or the username. Here we have the email, here we have the phone number, and here we have the website. Here we're going to update the user's email. So we're going to update the user set email to this new email over there, and then this is the ID of the person that we want to update the user. Next, we're going to delete the user by the ID. So we're going to delete the user from the user where the ID is 11. So this is the person we want to delete. So here we can view all the users by running the select all from users, and then also lastly we will show the structure of the user table. So I'm going to run it. Okay, so the student goes through is the table was already created. As you can see, the data does work now. Here we inserted a new user, and here we're updating the user, and now we're deleting it, and now we looking at all the users in the database. As we can see that ID 11 no longer exists in the database. So now I'm going to test it out with insomnia. So now we're going to do a get method to see all the runs available. So we got a 200, okay. Yeah, we have all the runs. So we have 81, 82, 83, 80, 84, 85, 86, 87, 88, 89, 80, 10. Next, we have to get a run by the ID. So we are going to get ID1. So there's another get method. We got a 200, okay, and then is ID1. Next, we're going to create a new run. So now we're going to create a post request. So yeah, we have the title, started on, completed on, miles, location, average base, and duration. So I'm gonna send it. Why did I? So there is a area. Maybe let me just check. I'm going to try and fix that error now with AI. Oh, it looks like it's only the get method that can work here, unfortunately, but this is supposed to run via the database, so there's the important part about everything. And that is it for tutorial 3. Thank you for watching.